Hello there, and welcome to the Sleep Lab. Tonight, we're looking at a ghost. 39 light-years away, a lone planet clings to a stellar corpse, racing through a year that ends before our workweek does. We have the coordinates and the cold numbers, but they can't tell us if the lights are on. Join us as we bridge the distance to a world that refuses to stay dead. Trappist, 1D sits 39 light-years from Earth. That distance is not empty space. It is a measurement of how far a mystery has traveled to reach us. We are only beginning to process what that means. This planet completes one full orbit in 4 Earth days. 4 days is a workweek for most humans. For Trappist, 1D, it is an entire calendar year. That compression of time reshapes every assumption we carry. Tidal locking is the mechanism holding this world in place. One hemisphere permanently faces the star. The other side never receives a single photon of direct starlight. This is not a metaphor. This is orbital mechanics operating at full consequence. Here is the question that will not leave this investigation. Does Trappist, 1D have an atmosphere at all? James Webb detected nothing conclusive. This mystery will be answered in the final minutes of this script. Stand on the terminator line of this planet. That is the boundary between the day side and night side. The red star hangs permanently on the horizon there. It never rises. It never sets. It simply exists, motionless. On the far night side, the star is completely invisible. No dawn ever breaks there. No sunset marks the passage of time. An observer standing there would only ever see neighboring planets and deep space. Those neighboring planets are not distant points of light here. Trappist 1E, the next planet outward, would appear larger than our full moon. That angular size is a direct result of the system's extreme compactness. This solar system operates at a different scale entirely. The host star itself looms 6 times larger than our Sun appears from Earth. Its light is dim and deeply red. That red glow falls into the far end of the visible spectrum. Photosynthesis, as Earth defines it, would struggle under this radiation profile. Stop. Consider this carefully. If photosynthesis cannot function under red dwarf radiation, what energy pathway would life use instead? Chemosynthesis exists on Earth near hydrothermal vents. Could an entirely different biological logic apply here? Trappist, 1D sits at the inner edge of the habitable zone. That position is not comfortable. It is a borderline condition. The difference between liquid water and a boiled dry rock here is measured in fractions of orbital distance. The term habitable zone is frequently misunderstood. It does not mean life exists there. It means liquid water could theoretically persist on a surface. Trappist, 1D sits close enough to that boundary to make every calculation unstable. Before James Webb launched, scientists proposed a water world hypothesis for this planet. A global ocean covering the entire surface. That model carried real scientific weight at the time. Webb's observations forced a complete reevaluation of that picture. A runaway greenhouse effect is the leading explanation for what may have happened here. Early oceans absorb heat. Water vapor enters the atmosphere. That vapor traps more heat. The cycle accelerates until oceans evaporate completely into space. This is the second unresolved question in this case file. If Trappist 1D once had oceans, where did all that water vapor go? Atmospheric escape mechanisms are known, but the exact timeline and rate here remains scientifically unconfirmed. We return to this in the final segment. Stellar flare activity from Trappist 1 is a documented and significant threat. Red dwarf stars are magnetically violent in their early lives. High-energy ultraviolet and X-ray bursts strip planetary atmospheres over geological time. Trappist 1D absorbed billions of years of that bombardment. Atmospheric erosion through stellar radiation is called photoionization-driven escape. Energetic photons strike atmospheric molecules. Those molecules gain enough energy to exceed escape velocity. They leave the planet permanently and drift into interplanetary space. Without a magnetic field, a planet has no deflection shield against this process. Earth's magnetosphere redirects solar wind around the atmosphere. Mars lost its magnetosphere early. Its atmosphere thinned to near nothing. Trappist 1D may have followed an identical trajectory. Venus offers a different and equally important comparison. It holds a thick atmosphere despite intense solar exposure. Its surface pressure is 90 times greater than Earth's. High-altitude sulfuric acid clouds reflect enough light to confuse even sophisticated telescope instruments. Here is a direct challenge to your logic right now. You assume more atmosphere means more protection. Venus proves that assumption wrong. A suffocating atmosphere is its own form of planetary extinction. Which version of Trappist 1D would be worse for life? 3 atmospheric scenarios exist for Trappist 1D right now. Each one carries a completely different set of consequences. Scientists cannot yet eliminate any of them. That uncertainty is not a failure of science. It is science operating at the edge of its current instrumentation. Scenario 1 is a completely airless surface. No atmosphere means no pressure buffer. Temperature swings between the day side and night side would be extreme. Liquid water under those conditions is a physical impossibility. Scenario 2 places Trappist 1D in the Venus category. A dense atmosphere of carbon dioxide traps heat far beyond any habitable threshold. Surface temperatures under that condition would exceed 400 degrees Celsius. That is hot enough to melt lead without difficulty. Scenario 3 is the Martian analog. A thin, tenuous atmosphere that Webb's instruments simply could not detect at current sensitivity levels. This scenario keeps a narrow window of scientific possibility open. Thin does not automatically mean absent of all interest. This is the third and most critical unresolved question in this entire investigation. Could any form of biology survive under any of these 3 scenarios? This is not a simple yes or no question. The full answer requires everything we have built so far. It arrives in the final segment. Extremophiles on Earth already challenge our definition of survivable conditions. Tardigrades survive vacuum exposure and intense radiation. Certain bacteria thrive inside nuclear reactor cooling pools. These organisms redefine the lower boundary of what biology can tolerate. But extremophile survival on Earth operates within a liquid water framework. Remove water entirely, and the biochemistry of life as we understand it collapses. No known Earth organism survives complete desiccation indefinitely. Water is not optional in our current biological model. The James Webb Space Telescope measures secondary eclipse photometry to probe atmospheres. It records how much infrared light a planet emits as it passes behind its star. The difference in brightness reveals thermal and chemical signatures. Trappist 1D returned an ambiguous signal. Ambiguous in telescope data does not mean empty. It means the signal fell below the instrument's current detection threshold. Webb's sensitivity is extraordinary, but it has limits. A thin carbon dioxide layer could exist and remain invisible to current measurement capability. Consider this directly. Every tool we use to search for life elsewhere was designed by a species that has only ever seen one example of life. We built our instruments around Earth biology. What if Trappist 1D requires an entirely different instrument logic to read? Trappist 1D exists inside a gravitationally crowded system. 7 planets orbit extremely close together. Their mutual gravitational tugging causes orbital resonance. That resonance keeps their positions mathematically locked in a precise, measurable chain. Orbital resonance is not random. It is a gravitational negotiation between planetary bodies over billions of years. Each planet's position influences its neighbors directly. Trappist 1D's orbital stability depends entirely on this fragile mechanical agreement. The red dwarf Trappist 1 is ancient. Estimates place it between 7 and 8 billion years old. That is nearly twice Earth's current age. Trappist 1D has absorbed stellar radiation for an almost incomprehensible duration. 7 billion years of stellar flare exposure has real consequences. Any early atmosphere would face sustained photoionization-driven escape over that entire period. The planet's current atmospheric state reflects that accumulated damage. Time itself became a destructive force here. The atmosphere question now has its clearest scientific answer. Webb found no thick atmosphere. The 3 remaining possibilities are barren rock, thin Martian analog air, or dense Venus-like clouds. No fourth option currently exists within confirmed observational data. The water question resolves here. If oceans existed, runaway greenhouse heating evaporated them. That vapor escaped via photoionization-driven atmospheric loss. What remains is either a desiccated surface or no surface signature detectable at current Webb sensitivity levels. Now the life question receives its scientific answer. Under Scenario 1, life as biochemistry defines it cannot survive. Under Scenario 2, surface temperatures eliminate liquid water entirely. Scenario 3 leaves one thin, unconfirmed margin. That margin is not confirmation. It is only an unclosed door. Trappist 1D's greatest scientific value is not habitability. It is definition. It shows precisely where planetary conditions break down. Studying its failure conditions sharpens our understanding of why Earth succeeded. Broken systems teach more than functioning ones. Every data point Webb collected from this planet refines the search criteria for life elsewhere. Negative results are not failures inside real science. They are boundary markers. Trappist 1D marks a hard boundary with measurable, documented precision. If this investigation changed how you see one distant, silent world, subscribe and share it. Science advances when more minds carry the same questions. This has been the Sleep Lab. Case file closed.